Okay, welcome back. So let's talk about what's called the standard form of the equation of a parabola. And it's given by this equation right here at the top. It says that if we have a parabola that has a vertex at a coordinate point hk and is magnified by a factor a, the function will be given by f of x equals a times the quantity x minus h squared plus k. So in order to identify the vertex, if we have the equation already given this form, finding the location of the vertex is easy. We use this value right here, h, as the location of our coordinate, our x-coordinate of our vertex, and we use this coordinate right here, k, as the location of the y-coordinate of our vertex. Right? So we can actually use that right here in this function. We say sketch the graph of the function y equals 2 times x minus 2 squared plus 3. Well, right away, noting the location of the vertex is easy. Our vertex must be located, according to this formula, at the point 2, 3. Notice that it's not negative 2, it's x minus 2, because if you put in x equals positive 2, we get 0 for the x term, and we get 3 for the y value. So on our graph, if we were to plot this, at the coordinate point 2, 3, we would have our vertex. Okay, what other points can we get? Well, the other things that we can find for our parabola is this vertical stretch. And essentially the way this vertical stretch might work, a good way of thinking about it, is that if you were to go to the left or right by 1 from the vertex, so what's left? Let's see, if we start at x equals 2, and we go to the left by 1, then we are at x equals 1. So let's think about what will happen at x equals 1. Well, we're going to get 1 minus 2 squared multiplied by 2 and add that to 3. So in other words, if we go to the left by 1, we would go up 2 to the point 1,5. If we went to the right along our x-axis by 1, so let's go right 1, that means that we are at the x-coordinate 3. What happens at 3? Well, again, you know what? I'll illustrate it this time by substituting into the equation. Y is going to be equal to 2 times 3 minus 2 squared plus 3. And what that means for us is that, of course, this is y equals 2 times 1 plus 3. And that means we're going to get y equals 5 as our coordinate. So, again, using our points right here to illustrate this, if we go 1, we should be passing through 5. Let me get my, let's get our coordinate point showing correctly here. And through the point 3, 5. Now how does that work for us? Well, if we were to actually take a graph of this function and show it, there it is, passing straight through those points. Well, what else do we know about this graph? Well, we know where the vertex is. The axis of symmetry is the vertical line that passes straight down the center of this graph. So if we plot this axis of symmetry right here, I'm going to highlight it here in yellow, probably not very easy to see in the graph, but you can see sort of. This axis of symmetry would be the vertical line x equals 2. That is the vertical line that passes straight down the x coordinate of our vertex. So there we go. That's our graph. This is how we produce one of these graphs for a standard function written in standard form. More in the next video.